11, 5 minutes. So, anything you want me to discuss? And most importantly, can you hear my voice?
Yes, can hear your voice.
Okay. Any questions so far? Mechanic is too easy. It's so hard to ask any question because you already you can solve any question easily. Is it what can I expect today? Okay, thank you, Azim. Fluid is hard. Okay. Fluid. If it is hard, it is solid mechanics. Solid always hard. Fluid always soft. How can you drink water or you breathe air if it is hard? Okay, no question, I assume. So, can we dismiss? Or you want me to discuss past your question? Okay, I think as I told you in WhatsApp, I will never take attendance for last week and this week. So in case any question, you are free to ask because my objective for today is to answer any question from you about fluid mechanics. I cannot answer every question, but I think for fluid mechanics, I hope I can solve your problem. So in case no question, what I will do is to pass your question, and during doing discussing the past question, you can ask or you are free to ask any question. You are free to interrupt me, and you are free to left the webback as well. Up to you. Okay. So let's we go to past your question. Share screen. Share. Okay, so I'm sharing to you past your question. We have solved question 2 yet previously, but question 3 is it's a bit the solution is a bit long. So you can see that the marks is really big. It is 17 marks. Okay. The solution is a bit long, but it is really what is it? It is easy to follow if you can understand about what is it, internal flow. Okay, so for this question, if we want to recap, you just need to know the from the what is it, the type of flow. Is it laminar? Is it turbulent? By knowing in the type of turbulent flow, then you can solve about for the friction factor. And then after that, you also can figure out the number for the minor losses. Then you can solve this question. Okay, it's a bit long, much calculation, but it's really direct. Okay, we go to question 4. Okay, question 4. Like oil at 20 degrees C flows over a 4.5 meter long flat plate with a free. Oh, okay. Sorry, I forgot to bring my pen. Just a while. Okay, like oil at 20 degrees C flows over a 4.5 meter long long plate with a free stream velocity of 2 meter per second. determine the total drag force per unit width of the plate. The density and kinematic viscosity of the oil is 20 degrees C and the rho is 888.1 kilogram per meter cube, and dynamic viscosity is 9.4 to 9 times 10 power of negative 4 meter square over second. So the question is to get the total drag force. So it's a simple question and simple solution. Okay. So as last week, we make it side by side. So you can see the question and you can see how to solve the question. Hope you still can see my screen. At least you can read the question. Okay, I think how to zoom view. And view. Okay. Uh, where's the zoom gone? Okay, yeah. 150, 125, 100. I think 80 should be okay. Okay. So okay, we are solving 4A. Like at okay, this one. Okay, so the equation that we are going to use is I hope you still can remember. Okay. F is equal to CD A rho V square over 2. Okay, CD A rho V square over 2. And for this question, okay, you need to get the force. You are given the plate area, you are given the density, and you are given the velocity over 2. But you didn't know the CD. Okay, how to get the CD for this type of question? Okay, CD. So to solve for this question, I think I have your USB. Okay, external flow. They refer to my slide. Okay, for this type of question, you need to know first the Reynolds number because you need to determine the type of flow. Is it laminar or is it turbulent? Okay, if it is laminar, okay, laminar is 5 times 10 power 5 and CF for this question is 1.33 over Reynolds number power of 1 over 2. If it is turbulent, CF is equal to 0.074 over Reynolds number over 4. So what you need to do now for this question is to get the Reynolds number. Okay, Reynolds number is equal to rho VD over mu or VD over mu. But in Exner flow, this question is rho VL over mu or VD over nu. Okay, don't know is the kinematic viscosity. So if it is given here, the kinematic viscosity, so you can determine the Reynolds number. V is 2 meter per second. Sorry, this one is L. Okay. L is 4.5 meter and the no is 9.429 times 10 power of negative 4. Okay, can anybody count for me? Can anybody please have calculated? 9 divided by 9.429 exponent negative 4. Oh no, dia bukan macam ni. I don't know how to use okay, can anybody please count for me? Oh, 9545. So it's equal to 9545. So 9545, okay, goes back to my slide. 9545, it is more than 9545 is okay. It is 9 power 10 power 4. So it is in laminar. So the equation that we going to use is 1.33 over in a number power of 1 over 2. So okay, let's go back. So we know that this is laminar. So when it is laminar, CF is equal to 1.33 over Reynolds number power of 1 over 2. So it is 1.33 divided by 9545 power of 1 over 2. Then you get the answer. Using what the answer you get here, just fill in the equation for the drag. FD equal to EF. Okay, this is the answer. And then A, area rho V square over 2. So CF is the number that you will calculate. The area is 4.5. Okay, 4.5 is the length. What about the width? The question didn't give the width, but what you need to solve is the drag force per unit width. So it's just 4.5 times 1. The density is 888. And the velocity is 2 meter per second over 2. Okay, then you get the answer. Okay, so I'm going to. Okay, you can screenshot if you want. Okay, let's go to question 2, question B. Okay, question B. During steady motion of a vehicle on a level road, the power delivered to the wheel is used to overcome the aerodynamic drag and rolling resistance. The product of the rolling resistance coefficient and weight of the fluid. Assuming the friction of the bearing of the car has a total mass of 950 kg, the drag coefficient of 0.32 and frontal area of 1.8 meter square, and a rolling resistance coefficient of 0.04. Determine the maximum power the engine can deliver to the maximum power the engine can deliver to the wheel is 80 kilowatt. Determine first the speed at which the rolling resistance is equal to the aerodynamic drag force. And the second question is the maximum speed of the car. Okay, I hope you have the screenshot of all this question, so I can erase everything. Okay, so let's solve for this question. First, what the question one is, the speed at which the rolling resistance is equal to aerodynamic rate force. So, they want you to give that the resistance, sorry, F due to drag is equal to F equal to resistance. Okay. Yes. And from this question, what is the V? Okay. V equal what? Okay. So you know that for FR, okay, you already know about it. FR is equal to mu N. And for FT is equal CD A rho V square over 2. Okay, so for this question, you just need to make sure mu n equal to CDA rho V square over 2. So, okay, CDA rho V square over equal to n. Okay, see, you it is 0.82. Here is 1.8. Is where is this density? Density of air, density of air. Okay, density of air is not given. So you can just search. Oh, what happened? Density of air. 1.225. Uh, 1.225, and the V is we are what we're searching equal to resistance coefficient is 0.04. Okay, this one 0.04, and N is which sorry, mass time G 950 times 9.81. Okay, so this is so, you just calculate and get what is V. Okay, so for the first part. Okay, we can do the snapshot. Okay, we go to the second question, the maximum speed of this car. Okay, the maximum speed. Last week I missed what? Okay, the maximum speed of this car. So how to get the maximum speed of the car? So you know that power. Okay, you are given here the maximum power the engine can deliver to the wheel. Okay, you are given the P, and you already know P equal to F times V. Okay, so power maximum power that the engine can deliver is 80,000. Okay, 80,000, and okay, F is equal to mu n plus 2 rho sorry CD A rho V square over 2. This one is CD. Okay. Sorry. Uh, okay. CD A or V square over 2. Okay. And then time V. Okay. So you can see here, this is just one equation. 80,000 equal to mu n. You know the value of mu n. Okay, just like part one, and then you know the value for CD A or V square over 2. Okay, from this question, you will get V cube because this is V square plus V is V cube equal to any number. So how to solve the question? Just form V cube, get and you will okay, then you will get the answer. Okay, simple solution. Okay, because for the equation is too easy. You just FD equal to CDA over V square over 2. Okay, so that's why I said I told you that for question 3, the solution is long, but it's really direct compared to the other question. Okay, again before we change to next question. Okay, for question B, this is part 1 and this is part 2. See. Okay, for question C, determine the direct force acting on the sign. Okay, as 3 centimeter and is subject to normal wind up to 150 kilometer per hour at 10 degree. R equal to 0.287 kilopascal meter cube per kilogram Kelvin and 100 kilopascal. So you know P, you know the temperature, you know the R. Okay. P, P, MRT. Okay, so to solve this question is determine the direct force acting on the sign. Okay, for this question, the equation is still same. Sorry. Okay, F D equal to CD A or V square over 2. Okay, then for CD, okay, how to get the CD? So what you need to do is go to the slide again. And okay, go for this type. Okay, this table is really important for you. Okay, so you need to find which one is similar. Okay, the case is a circular and directly normal the wind is normal to the circular sign. So find it from here. Okay, it is a square road, rectangle road. Okay, this is circular, but it is a road. Okay, so it's totally not elliptical road, not triangular, semicircular shell. Sorry, the case, but this look like this case. Okay, thin circular disc. Okay, A is equal to pi d squared over 4, and the velocity acting to the surface. Okay, so we can choose this figure. So for this figure, CD equal to 1.1. Okay, go back to the question. Okay, now you know that from the table, CD is equal to 1.1. So just solve the question. CD equal to 1.1. Okay, A, okay, pi d square over 4. Okay, or pi r square, up to you, which one you love. Okay, then density, just take the density. And then for the velocity, the velocity is 150 kilometer per hour. V equal to 150 kilometer per hour. So you need to change it into meter per second. So hour, okay, 1 hour equal to 3,600 second. Kilometer, 1 kilometer is equal to 1,000 meter. So 150 times 1,000 divided by 3,600. So how much is it? 150 times 1,000 divided by 3,600 is 3.6, 41.67. 41.67. Okay, so you got the V square over 2. Okay, just include all the value and then you can solve for FD. Okay. Okay, I think it's an easy question. And then to make the question, for the second part is determine the bending moment at the bottom of the pole of its pole, whose edge from the ground is 1.5 meter. Okay, the pole whose height from the ground to the bottom of the sign. Okay, so you know that this is the sign. It's a bit hard to make a straight line using this. Okay, this is the pole, and okay, so this is the sign. Sorry, I cannot write properly. Okay, you know, you already know, you already calculate the force, and you got the force here. Okay, 1.5 meter is from the ground to the bottom of the. Okay, so the force will acting at the center. So you got extra here, you need to calculate. So it's equal to the radius of the circular. Okay, the diameter is 50 centimeter, so the radius is 0.25 meter. So you know that the D now. Okay, what you need to calculate is the moment. Okay, so what is the moment here? Okay, so moment is equal to FD. Okay, get F from the value you got before, and D is 1.5 plus 0.2. Okay, so you can solve this question. Okay. I hope you can understand. Okay, finish snipping this question. Okay, let's go to the first question. Okay, you can understand? Okay. Thank you. Okay. Oh, thank you. Okay, we go to final question. Question 5. Water is flowing through two identical rectangular sections with unfinished concrete surface. The width and the height of the flow section is 3 meter times 3 meter. So we go to the final slide. Open channel flow. Okay. Okay, you know that this question rectangular channel, unfinished concrete, and the width of the channel and the flow section is 3 meter times 3 meter. Determine the flow rate of the water if the bottom slope is 0.002. Okay, so from the final slide, okay, what is the question is about is to determine the flow rate. If you know the I think the what is it, the slope and the what is it okay, just like this question. You know the okay, you know the slope, you know the height, so you need to determine the v dot. V dot that's the question. This is a question. V dot equal to a over n. Oh, okay, it's fine. Okay, V dot is equal to A over N AC L hash hash 2 over 3 and KAN AC L hash power of 2 over 3 and the slope power of 1 over 2. So, okay, determine the flow rate. Okay, so V dot equal to A over N AC L hash power of 2 over 3 and slope power of 1 over 2. Okay, you know A equal to 1 and you can get N, okay, the rectangular channel with unfinished concrete. So when you know this is unfinished concrete, go to the slide again. Okay, find the channel with unfinished concrete. Okay, unfinished concrete. What is unfinished concrete? Okay, this is concrete unfinished. So the value is 0.014. 0.014. Okay, this is from the slide. Okay, for Anesh. Okay, AC. Okay, how to get the AC? AC is the area of the channel. So AC is 3 times 3. And for unhash, okay, how to get unhash? Okay, one more is the weighted perimeter. Okay, weighted perimeter is 3 plus 3 plus 3. Okay, I hope you still can remember about for the slide, which I told you to get the uh, what is it? Okay, the LH. Okay, LH is equal to AC over B, where AC is the area and P is the weighted perimeter. Okay, the perimeter is weighted by water. So LH is equal to P. So LH is equal to 1. SO is equal to 0.002. Okay, it's given from the question. Okay, just put all this information into the equation and you can solve the question. Okay, for part one. Okay, is it okay? Okay, finish part one. Okay, we go to part two. Now the sorry, the flow rate of the water. Sorry, this one is two identical rectangular channel. So to solve this question, okay, we dot v dot is equal to 2 times this v dot. Okay, v dot for one channel. Okay, 2 times v dot for one channel. Okay, and then next question is now the two channels are combined. So which say that for the first question, it is two channel 3 times 3. Okay, it has divider at the center. For second part question, okay, this is the first question. For second part of the question, it's a combined channel. So this is 6 and this is 3 and this is 3. Okay, so all is same. For the second part is still equal to 1 and equal to 0.01. But AC is now different. AC is 6 times 3. And the weighted perimeter is now 3 plus 6 plus 3. So this also affect the R hash. R hash equal to AC over B. So AC is 18 and P is 12. Okay, you got the numbers. So you can calculate now the V dot for this question. Okay, you can and then the answer, compare this answer to the previous answer, and then will get the percentage. Is it increase or decrease? Okay, finish part A for question 5. Any question? No question. Okay, part B. Part B is easier. Water at 10 degrees C flows in a 6 meter wide rectangular channel at a depth of 0.55 meter and flow rate of 12 meter cube per second. Determine the critical depth. So how to determine the critical depth? Just go to the slide and find equation for YC. Okay, YC is the critical depth. So where is it? YC. Okay, YC is equal to V dot over GAC. So for question one, So for question one, YC, Y critical, is equal to V dot divided by GA. Is it GA only? YC G B square. V equal to V dot over A, and then YC dot square over GB square power of 1 over 3. Do I make a mistake here? Okay. You can just use this equation. V dot divide by GB square power of 1 over 3. Okay, I think that's much easier. I forget the equation already. V dot square over GB square. V dot square over GB square power of 1 over 3. Okay, just include all the information. V dot is 12 meter cube per second. 12 divided by G is 9.81 and B rectangular channel at the depth of 0.55. 6 meter wide. Okay, 6 square. Okay, 1 over 3. And you will get the answer. Okay, for question 2, whether the flow is subcritical or supercritical. How to compare? So if Y is lower than YC, so, and then if Y is greater than YC, which one is supercritical, which one is subcritical? Which one is supercritical? Critical. This one is subcritical. Okay. And then lastly, the alternate depth. Okay, for this question, okay, my slide and so where is it? Okay, this one, okay, for step 2, determine the alternate flow depth with the same specific energy. So find the ES. Okay, ES, the specific energy. ES equal to Y plus V dot square over 2GB square Y1 square. Okay, put all the information. You got the value for ES. And then what you need to do is find ES2. Okay, because you have the ES. Mean the specific energy. You have already found the specific energy, but you need now is the alternate depth. Okay, you need now is Y2. Okay, so use this equation and then to get Y2, either you calculate by yourself, okay, by manipulate this equation, or what you need to do is just Google for equation solver in the internet and then try just information and then you will get the alternate depth. Okay, that's all. Okay, finish already for previous year question. I hope you gain confidence for your exam for this semester. Okay, the question, I think it's normal. In university, you cannot expect the question change so much. Okay, the question is different, totally different. But the trend is there. You can get the trend. Okay, the trend always same. Okay, so try to solve several previous equation, and then one more is from the note. The example that I given is enough for you to answer the question. Okay, but please don't read the solution. Try to stand on it. Okay, so that's all. And then just one more. You have done almost everything except the final exam. But one more is you also need to do quiz. Okay, so for this week, I will give you a quiz online in the Udemy. Okay, there is 5 questions. I will give you 5 different quiz. Okay, so you can click and solve one by one. Okay, all the quiz from quiz 1 until quiz 5. Okay, one quiz is just question and specific topic. I will let you know in front of the topic. So use any of your time, your free time, try to solve the question. It is MCQ, multi choice question. Okay, just to solve. Please solve the question and then give the correct answer. Okay, that's all. Okay, I hope everybody has submit your assignment and also lab report. In case you forget to submit your lab report, please check again. So let me know. Quiz tu ada markah? Yes. Quiz has 10 marks. 2 marks for each question. For each quiz. I made 5 quiz. It is to make easy for you to solve the question. Okay, any free time, solve one question, and then for the second free time, solve another question until you solve all these 5 quizzes. Thank you. That's all. Tak ada limit time limit. Okay, have time limit. Or you can contact all your friend and to solve the answer. But there is no dedicated time. You can solve any time you want. Okay, within this week, you can solve anytime. Okay, the limit time for each question for each quiz is about half hour.
So how about the lab test for the
Okay, lab test is this Friday 8 o'clock, 8 p.m.
this Friday?
No, Thursday. Sorry.
Thursday. So it will be subjective or objective, sir?
Yes, it is subjective. Okay, it's almost same with the other lab test.
For how many questions, sir?
I think three question only.
3 questions. Okay, thank you, sir.
Okay, just
Sir, I have a question.
Yes, okay.
Lab is the last one is lab 5, right? Yeah, Renault number. That's all right.
Can you repeat again?
The lab is the last one is the Renault number, right, sir? Lab 5.
I didn't remember. Maybe. I don't remember. I didn't remember.
Renault number only,
Just
right?
okay. Maybe. I didn't remember. But there
ada
is
lagi lah ni.
tak, lab they just 5 lab. But I didn't
Yeah.
remember the number. Okay, but if I not mistaken, I can say about the topic of the lab. Okay, Renault number, filtration, Bernoulli, and then force impact of jet, and one more is the stability, buoyancy, and stability. But I cannot remember which one is number 1, number 2, number 3, and up to number 5.
Okay, thank you, sir.
You're welcome.
So the lab
Yes.
test is the question is up clear or calculation.
Okay. Lab is we want to evaluate your psychometric. Okay, psychometric is how you do it. So because we cannot see how you do it, so we will ask about how you do it in a question. It's not so what is it? It's not so so theory, but how you are going to observe, how you are going to do this and this, and just like that. I nearly give you the question. I have given some of the question in here when I talk about it. Okay, that's all.
Okay, thank you, sir.
Okay. I hope you didn't notice I give the question. Okay, any more questions? I hope not about the lab test, or else I will give the whole question. Okay, I think no more question. Okay, thank you. Thank you for your time. Thanks for your apa? For your time for the whole semester. Watching my YouTube. Stay with my class, although it's just online. Okay. Okay, so again, I cannot remember. I cannot remember, but I don't know each of you. So in case for next semester when we meet, okay, I'm so sorry if I cannot say hi to you because I cannot figure out which one is Ho, which one is Aiman, Jackson, or anybody here. Okay, but feel free to say hi to me next semester when you meet me.
Inshallah,
Okay,
sir.
thank you.
Inshallah. Thank you,
Okay,
sir.
thank you. See you. Okay, all the best with your examination and quiz and everything. Thank you.